Okay. So we want to look at the probability distributions that we started last week. So this is probability distributions 2, where this one, the concentration is going to be on the Z distribution and that of the student T distribution and a bit of chi-square. So let's try and see if we can finish the Z distribution and then the T distribution today, so that I left with only the chi-square distribution. I'm really tired, but we'll try. So for the normal distribution, of which we've all encountered it in one way or the other, has a PDF given as this. That is the probability density function of the normal distribution is given as the f of x is equal to 1 on the sigma multiplying square root of 2 pi multiplying e to the exponent of negative half multiplied x minus mu divided by the standard deviation all squared. So this is the PDF of a normal distribution, like we've been doing for the other continuous random variables, that if you want to find anything, then it's about you integrating from the negative infinity to infinity of whatever function that has been given to you, and that's supposed to give you one. That is the PDF that we are talking about. But for the normal distribution, this is the PDF that we have. But in this case, it's not about we integrating, but it's about we being able to make some calculations with regards to the mean of that particular distribution and its standard deviations. So if you talk about the normal distribution, it simply has to do with the number of standard deviations a particular score has from the mean of the distribution. So if the mean of a distribution is represented as, let's say, mu, and then we want to look at the number of standard deviations, then if this is the mean, there can be a deviation of 1 unit to the left. So that will be plus 1 of the standard deviation. If it is 1 unit to the left, then it will be minus 1 to the left of the mean. Now for the area that is bounded by the curve, and then the x-axis is always equal to 1, because we know that the probability should be equal to 1, because you cannot have a probability to be greater than 1. So we can, based on this, and calculate for various probabilities that are associated with certain values or scores of values. But before you can use the standard Z distribution to do that, then there is a way that you will use to convert whatever score that you have to the Z distribution. And that one, we use the formula Z equals x minus mu divided by the standard deviation. Now, if you pay attention to this, you realize that the mu that we have here and then the sigma that we have here all represent population parameters. So you have the population mean given as the mu, and then we have the population standard deviation given as the sigma. So once you are able to convert whatever score that you have to the standardized Z score, then you can use the Z distribution to calculate for whatever probability that you've been asked to do. There are some few properties of the normal distribution that we should note whilst we are doing calculations. And the first property there is that the normal distribution is continuous in nature. So that is why I said the PDF. We know that PDF has to do with the continuous variables, and then the PMF has to do with discrete variables. And then the normal curve is a bell-shaped and has a single peak at the exact center of the distribution, where the exact center represents the mean of the distribution. Very soon we will have a look at how the bell shape and its diagram is. And it is asymptotic to the x-axis. Asymptotic to the x-axis in the sense that it does not touch or cuts across the x-axis. So if you have your x-axis as this, then you realize that the distribution is something like this, and you will not, this one is even kurtosis. You have your distribution like this. So it doesn't cut across the x-axis. So we say it is asymptotic to the x-axis. And it's also symmetrical about the mean. It is symmetrical about the mean that we said it is bell-shaped, but it's peaked at only one point. So assuming the peak is here, and that peak represents the mean. So if this is the mean or mu, it is symmetrical in the sense that the side to the left of the mean is the same as the side to the right of the mean. And if you are to fold this along the mean, you realize that the left side will perfectly fit to the right side. So you see it is symmetrical about the mean. And then the higher the standard deviation, the less compact the bell shape is. So for the normal distribution, of which we refer to it as the Z distribution, we call the Z distribution, it is coming from the name there, standardized Z or standardized normal distribution. So because of this Z, we've been using S to represent sample standard deviation. So using this S would have confused a lot of students. So it's coming from this Z within the spelling of the standardized. That is why they call it the Z distribution. It's not anything that's abstract. So the mean is 0. If the mean is 0 and then the standard deviation is 1, then it means that your mean will be at the center, and then from the center to the end of this side represents your standard deviation. And this one has positive values to the right side, and then to the left side of the mean will have negative values. Yes, like I said, the total area under the curve is 1, and the curve is symmetric, as we've said, about the mean. So half is above the mean and half is below the mean. So this is the explanation to what I just did. And if we say it is bell-shaped, this is the shape that I'm referring to as bell-shaped. And it is peaking at only one end, like this. So the standardized normal table, as we've been using, and then for the purpose of this discussion, you see that the probability less than a desired value for Z will be the values that are to the left side of that particular score that we are dealing with. We will soon look at probabilities and then we see. For instance, if you pick this example and you've been asked to say, find the probability that there is a particular Z score that is less than 2. Because this one has been given as the Z score less than 2, there wouldn't be the need for us to convert it to a Z score again because it has already been given as a Z score. So the duty of us now is to make sure that we have our normal distribution curve drawn nicely like this. But we know this is 0, that is the mean. So if it is 2.0, then it's going to be somewhere at this point. 2.0 means 2 standard deviations from the mean, that is to the right side. So we have it somewhere here. So it left with us to find the probability that z is less than 2.0. And that one, we have to read it from the normal z distribution table. And this is the table. So if you want to read it, we had p of z less than 2.00. So this is what we will do. This is your z. And then if you pick those at your row here, those represent the numbers up to the first decimal. So you have your 2.0 here. And then to the column, you will be looking at the second decimal. So 0.00 is here. So you have 0.00. So it will be 2.00. So you are going to trace in terms of row and columns and then figure out the value that you will get from the intersection of tracing the row and then the column. So this and then this is giving us a value of 0.9772. So it means that the probability that the z is less than 2.0 will be equal to 0.9772. So that is the probability that you have. If you are to convert it to percentage terms, then you can say that you have 97.72%. So you can say that about 97.72% of the scores will be less than 2.0. So this is an illustration of how to read the values on the z distribution. So if you have been confronted with a task whereby you are supposed to find probabilities for certain values. So to find the probability that a certain number A is less than the variable less than a certain number B, when your X is normally distributed, then the first thing is to draw the curve for the problem in terms of X. Yes, but you now translate the X values to the Z values. And after that, you use the normal standardized table to calculate or trace the values for Z. And then you compute the various probabilities that you've been asked to do so. So let's look at an example here. The example is, let X represent the time it takes in seconds to download an image file from the internet. Suppose X is normal with mean 8.0 and standard deviation 5.0. Find the probability that X is less than 8.6. So with this, we've been given it in terms of X. The duty that we are supposed to perform here is to convert from X to Z score. So the Z score will be given as X minus mu divided by the standard deviation of the population. So this is going to give us 8. So 8.6 for that of the X minus the mean as stated in the question as 8.0, and this divided by the standard deviation, which is 5. So this is going to give us 0.6 divided by 5, and this will be equal to 0.6 divided by 5. So that will give us 0.6 0.12. So now you have your z to be less than 0.12. So this thing that we have done here, we say that we've been able to convert from the variable that was given to a z-score. And this z-score that we have here is the same as this that we have. So if you are able to calculate for this particular probability, then it will be the same as this probability that you were given in the question to calculate for. So now it's our duty to go back to the table and then trace the z-score for 0.12. So let's do that and see what we will get. So 0.12. So we are going to get 0.1 here. And then 1, 2. So we will trace it with 0.2. So you have 0.12. So it's going to be from here. Yes. So we are going to get this as the probability 0.5478. So we have it as 0.5478 as the probability. So it means that about 54.78%. So we say that, let's represent the time it takes this to download an image file from the internet. Suppose it's this. So it means that it takes about let's say 54.8% of the time to download what? Less than 8.6 items in terms of seconds. So that is the interpretation. So if X is less than 8.6, then it means that it takes less than 8.6 seconds to download an image from the internet. So the probability that it takes 8.6 seconds to download the image file from the internet is 54.78%. Yeah, so it has been illustrated here nicely for us. So once you have this and your mean is 0, you've been able to calculate for the z-score and you had 0.12. So the rest is for you to go back to the table and then do that calculations. So this is the same thing that has been done here. So there is another question that suppose X is normal.
Hello, sir.
Yes.
Hello.
Yeah,
Sir,
hello.
do you have to sketch the drawing whenever you finish?
Yes, please.
Okay, thank you.
Because that will guide you to know where your z-score lies.
Okay.
There are situations whereby you have two tails, either to the left or to the right. So if you draw, it will give you a clearer picture or idea about where you are likely to calculate. But you see, the ones that are dealing with only a single value, you realize that even if you don't draw, you can calculate it with ease. But situations like this, for this particular one, for instance, if you don't draw, you find difficulties calculating for the probability.
Okay, thank you very much.
So we say suppose X is normal with mean 8.0 and standard deviation 5. We've been asked to find first the probability of X greater than 8.6. So this one, because we just calculated for X less than 8.6 and we had it to be 0.54 5.78. Then, if you are to calculate for x greater than 8.6, then you can say that the probability of x greater than 8.6 will be the same as 1 minus the probability of x being less than 8.6, right? So now we've been able to change this one to a z-score. So this will now be the same as 1 minus the probability of z being less than 0.12. So once we know this, then we can subtract from 1 so that we get the probability of x being greater than 8.6. And that is what has been done here. So the first one that you did, you realize that our interest was here, such that it was less than. So this part wasn't shaded. But now we are interested in the part to the right of 0.12 that has been shaded. But we know the total area being bounded by this line and then the curve will be equal to 1. So once we know this part, if we subtract from 1, we should get the remainder of this. Now the second part of the question is asking us to calculate for the probability that 8 is less than x and is less than 8.6. So it means that x is likely to lie between 8 and then 8.6. So problems like this, then we have to convert this one to z-score. And then we convert this one to z-score as well. So converting it to z-score. Then for x equal to 8, then you are going to have your z-score to be equal to 8 minus the standard deviation, which is the same as 8 divided by 5. So this is going to give you 0. So it means we will be interested in the probability that z is less than 0. Now, we will also be interested in the probability that our x is equal to 8.6. So that one too, when we convert this to z-score, then we had the z-score to be 0.12. So we'll be looking at the probability of z being less than 0.12. So now let's look at this. If we are to illustrate this in a diagram like this, this is 0, which is the same as the mean. And then we are looking at, no, this one, sorry, z is supposed to be greater than because of this. Please check it. Z supposed to be greater than 0. And then rather less than 8.6. So we will have our 0.2 to be somewhere here. So 0.12 to be here. So if z is greater than 0, then it will be somewhere here, right? But this one too, we are also interested in z that is less than this. So that z being less than that will fall somewhere here. So it tells you the area that we are interested in will be this place. So from here and then this point. So we are to calculate for this particular area. So with this, what we will do is we have to now look out for the probability that our z is less than the 0.12 from the table. And then we look out for this. After that, we take the difference and then we get this probability. But we have already calculated for p of z less than 0.12 and we had it at 0.5478. 8. Now let's calculate for P of Z to be greater than 0. So we are going to look at Z score for 0. So that will be 0.00. So we have 0.000. So we are getting a result of 0.5000. So here we are going to get 0.5000. So in this case, the probability, let me do it here. The probability of 8 less than x less than 8.6, which is the same as the probability of 0 being less than z less than 0.12 will be equal to the 0.5478 minus 0.500. So this will give us 0.0478 as the answer. So you have to sketch it, and that will guide you to know the exact area that you are interested in. Any question on this?
Sir,
Yes.
please, when it comes to the table, will you be given the table? Supposing in
Yes.
exam.
If it's an exam, you'll be given a table. Mostly. You have to be given the table because you can't be keeping everything like this in your head. So the table they normally give. But sometimes if you need a table and you don't ask, they might even forget that they are supposed to add tables. So if you have a question that you think it demands such a calculation and you will need a table, you quickly prompt them. Before you know, they have it, but they are waiting for someone to ask before they bring it out.
Okay, sir.
Okay. So this is the illustration of what we just did. Now there is another nice question here, that if X is distributed normally with mean of 100 and standard deviation of 50, find the Z value if X is equal to 200. And I think this one, it's easy to calculate. So just use this and then you convert it to this score. Now there are some questions that you might not see the full readings that you are seeing in terms of English like this, but they will write it in terms of mathematical notations. So if you see them writing X is normally distributed with mu and then sigma squared. So if you see this, then it means that X is normally distributed with mu as this and then the variance as this. So you can get a question and you realize that this question would have been written as, let's say, X is normally distributed with the mean which has been given as 100 and then the variance as 2,500 like this, and ask you to find the Z value if X is equal to 200. So if you get the question and it's like this, then you have to take note that this particular value that you are having here is not the standard deviation, but rather it is the variance. So for you to get the standard deviation out of it, then you have to take square root of the variance to get your standard deviation. But if you are fortunate and the question is being stated like this, then you can easily fish out your standard deviation and then the mean from the question. So on the final examination in mathematics, the mean score was 72 and standard deviation was 15. Determine the standard scores of students who scored the following. So this task is for you and you are to do it, let's say within 5 minutes, you should finish. So you have this. Just write this down so that I project the table for you, or you might not even need the table for this. So you have to find this. So we are waiting for you.
Hello, sir. Can I have the formula?
I'm still waiting for you.
Sir,
Yes.
the first one I got negative 0.8. The second one I got 1.4. And the third one is 0.
0.
Yes,
Yes,
sir.
sir.
Yes, third one is 0. 72 minus 72. 0.
Is that George?
No,
Oh, that's
Joseph.
Joseph. Okay.
Shama District NDC Youth Organizer.
John Chiman Wyden.
Okay. So how did you get your negative 0.8?
So you subtract the 72 from the 60.
Okay. So your z score will be given as your x minus mu divided by your standard deviation. So the a part will give you z to be equal to 60 minus 72 divided by, so this will give us negative divided by 50, and that gave you 0. Sorry, negative 0.8.
8.
So you are supposed to do it the same way. So now with this same problem, right? Assuming the question that we were supposed to look at was to calculate the probability that the probability that your x will be greater than 60, and then that is the first one. And then B, the probability that x will be less than 93. So let's do that and see what we get.
So I think you have to have the table. You have to have the table.
Are you done with it? Hello?
So I'm not seeing topo.
Why?
So let me
Is
give
it
it a
about
try. The first one I
okay?
got 78.1%. Then the second one I got 91.92%.
So
And
you
then
let's
what
go
I'm
there
going.
and see how you did your calculations before we come back to the table. So this is it. So how did you start and how did you end up at that 71 stuff that you are talking about? Hello?
Hello, say I'm coming. So
Yes.
I started with finding my the scores. That is the 60
The
minus
Z
72 out of 15. Yes, Z. After getting
minus
my Z
7
score, I went to the table.
out of
60 minus
no, we are
72.
doing it step by step. So we want everyone to follow.
15.
If there is an area where there is a mishap, then they can also give an input. So 15. And this gave you
Yes, please. 0.8.
negative 0.8.
8.
So 0 to it, right? Mhm.
Yes, sir. So then from there, I went to the table.
Okay. No, you didn't
Then
draw
I
your
got,
distribution.
so I drew my distribution.
Okay. So you had
Uh,
something like this.
yes,
So
please.
if this is 0, and then we can have our negative
Negative 0.
0.80 somewhere here,
Yes, please.
right? Okay.
Yes, sir.
So then you went to the table.
Yes, sir.
Okay. Mm-hmm.
And from the table,
Okay.
8. And then 0.00. The values
So
there,
no, I only heard 0.00. I didn't hear what you first mentioned.
so I said, when you look at the Z score 0.8.
Okay, 0.8.
You locate 0.8. That is 0.0, 0.1. Then you move to the right side, 0.00. The value there is 0.7881.
Yes.
So I chose that value as, then I found percentage of it. That I multiplied by 100%, then I got
So
78.81%.
yes. So in terms of the probability, what you have even found is still a percentage, right? Or is a probability. So you get 0.788. Where did I get to?
0.7881. That's the probability.
So your P of Z being less than, or is it greater than?
It says greater than 60.
Okay. So you had greater than 60.
60.
Now let's look at the trick here. When you drill this thing that you have here, right?
Yes, sir.
Is the same as your X being exactly equal to 60, right? Or your Z, this one should have been negative 8.0 or 0.8. Negative
0.81.
Yeah, I was about to ask a question, but you are explaining.
Okay. So the moment you have this here, and what you have calculated for is the less than part that you have calculated for, right? Then what you are supposed to do is that you subtract that value from 1 to get the probability of being greater than. So you see that your probability of Z greater than this will now be the same as 1 minus the probability of Z less than or even being equal to the 0.8 that you have. But you had this one to be equal to 0. Was it 7881?
Yes, sir.
And this will give you 0.2119, right?
0.2119.
Yes. That is the
Yes, sir.
probability that you are interested in. So you have to pay particular attention to these signs that you have here. So our interest,
Okay, sir, thank you.
was the area that will be left to the right side of this, but not necessarily to the left side. Now, what about the second question?
The second one, I got 0.9192.
How did you do that? You had your Z to be equal to 93 minus 72 divided by 15, and this will give you, is it 20?
I got
you have 21 divided by 15, and that will give you, what did you get for that?
1.4.
1.4. All right. So let's say 1.400 like this. So you now have your distribution as this. So if this is your 0, let's say your 1.4 lies somewhere here. So if it's greater than, then you are interested in this particular what? No, it's sorry, it's less than.
It's less than.
Less than. So you are interested in the area that is below this one. So you just look out for it there. So you are looking for the probability of Z less than 1.4. So this will be equal to, now you go back to your table and look out for 1.4. So this is your
1.400.
1.400. So that is here, right?
0.19. 0.9192.
9192. Have 0. 0.9192. Yes, so that is the probability. This time we are not going to subtract from anyone because the area that we are interested in is what we've just found. So that is the probability. But I believe we are all able to get to a point, or we are all able to get this.
Yes, sir.
But sir, can I ask a
Yes.
question? So when you are drawing the distribution, when you draw the diagram, I thought you said the middle is a mean. So
Yes.
I thought the mean given in the question will be written at the center, where we always put 0 there. The diagram.
Yes. The mean given in the question is supposed to be written in the center. So for instance, the mean here would have been the 72, right?
Yes, sir.
So if it is the 72, then it means that we are now coming to write 60. But the moment we don't have a table that will allow us to find the probabilities for this, but rather we have to convert from the raw state like this to the standard Z distribution. Then we have to convert this mean also as well. So if we are converting the mean, then that is going to give you 72 minus 72 divided by the standard deviation, which is 15. So that will give us 0 divided by 15, which is 0. That is why we've been writing the 0.
Okay.
Then you convert the other ones out.
Sir, please, I want to add something to it. The normal distribution that you are talking about, the total area should be 1, and then in between, which is the mean, is the initial point, that is 0. So that's where that we are going to get either a positive or negative values, and then the areas that you are finding, that's where you are not getting anything more than 1, or if it is more than 1 component, you have to subtract. That is, from here is 0.5, another one is 0.5. So you have to start from the middle, which is the initial point, which is 0. I don't think you should bring that number there, that value of mean there. It will make the work so difficult for us. Thank you.
Are you understanding his explanation as well?
Yes, sir.
Or the better way that you can also understand this is that we are looking at the Z distribution as the number of standard deviations that a particular score is going to have from its mean. So if the mean is 72, then the standard deviation of the mean from the mean will be equal to 0. Then if we move further to the left or to the right, then you get different deviations from the mean that is 0. Another question, of which we've been given the mean time taken by 500 male students to solve a problem, is 151 seconds, with a standard deviation of 15 seconds. And assuming that the times are normally distributed, find how many students takes between 120 and 155 seconds. And then the next one is for us to find the number of students that takes more than 150 seconds. So you see, this question is quite different from the ones that we have been solving. The ones that we've been solving, we've been looking at the probability that a particular score will range from one point to another. But this time we are looking at the number of students that will take between this seconds and this to solve the problem. So how do we tackle it? Anyone to give it a try, or we should move on? Okay.
Sir, let me
Sammy wanted to try
this question. No. Sir, I'm asking a question. Sir, are you going to solve the 120 different, then 155 different, so that you sum them together?
This thing that you are seeing here,
No, they are,
it's like
it's
you
like
giving 120 less than x. Sorry, 120 less than x
Yeah.
less 155.
Okay, I've gotten. Thank you.
Okay, should I allow
So
you
with
to
this,
try?
we find
Sir, yeah, coming.
Okay, you try, and this time too, I want to hear the females as well. Or the four round
Sammy, Madam Lorina, way. No, what's your phone?
Sir, please do it with us.
We should do it there.
that's it.
Yes, please.
No. Oh,
So
single
with
out.
this, so the first thing that you have to check from this, you have to look out for your mean, and then you look out for your standard deviation. So what is the mean and the standard deviation given in this particular question?
The mean is 500 and the standard deviation is 15 seconds. 15.
The standard deviation is 15, but I'm not taking the mean that you've given.
The new is not 500. Oh, iPhone.
The mean is 150.
151.
154.
Yeah, it's
Yes, so 151.
one.
Yes. So these are the first two things that you have to look out for before you approach this question. Now, the first thing that after getting this we have to do is to now try to see and convert these ones from these scores that to a standardized score. So in converting it to a standardized score, one thing that you have to put it at the back of your mind is that once we are talking about seconds, between 120 seconds and 155 seconds, then this means that there is a possibility that we will record 119.5 seconds as what? Part of 120. Is that not the case?
Yes.
Yes. So it means that all those that will take 119.5 seconds will also be part of this category. So we have to cater for that because this is a continuous distribution. So that is where we will start from first. So
Hello,
we
sir.
will look at, yes.
I think it's between 120 and 165. So I don't know why 195.
I didn't write 195. I wrote 119.5.
But it's not up
That's
to the
one.
number, the statement given.
This is a continuous distribution, and all figures that are between 119.5 up to, let's say, 119.9 will be rounded to 120.
Okay, so if you want to make it that, okay.
Yes. So we have to cater for that. So that is going to give us 119.5 minus the mean, which is 151, and this divided by the standard deviation, which is 15. And this, what we will get? Those of you with calculators.
-119.
Negative 2.1.
So you had everything to be negative 2.1.
1.
Okay, so you can make it 2.100 because of the distribution that we'll be reading from. And then we come and look at this
Hey,
one.
what I have negative. Okay, okay, I've seen it. It's okay, you can go on.
Okay. Now let's look for this one too. So we are going to get 155 minus 151 divided by 15. And what are we getting for this one too?
Two point 0.2666666.
0.
0.2666666.
0.2667.
Bryce, Diapura.
Semester protocol.
Hey. Okay, we say yes, Sam George.
No, no,
Okay, we say Sam George. I'm engagement here soon. Right. What can we say Sam George today? Send next week away. Send next week away. What can we say Sam George next week away?
Sam George in your name. And you're George for dinner.
I don't know, I have a paramba. Obi and the now, Obolofi. No. I'm control me. I'm your sham. Man, I'm mission. The George Kuno correct.
George one, Papa.
Anyway, Joe.
You.
I say, Miss Marin, I tell you, engagement. I say, if you are not by me, DMI.
Matters.
Hello. Hello.
Hello.
Yeah, hello, sir.
Sure.
Can you hear me?
Yes, please.
Okay. So you were here.
Yes, yeah, you are right.
Okay.
Yeah,
And you said
network
you
was off.
oh, so you had
Yeah,
0.
you said that.
0 point.
What decimal places we are going to get? 66667.
0.66.
0.22. No. Please, it's 0.26666.
266, like let's say 7. Like this.
Yes, please.
Okay.
Yes.
Ideally, this is the value you should get. But now let's look at this. At this point, we spoke about the fact that values that were between 119.5 could have potentially been rounded up to get 120, right?
Yeah.
Now, is there a possibility that values between 1, 5, 5.1, 0.2, 0.3, 0.4 to also be included as part of 155?
Yeah.
Yes,
So
yes,
it
yes.
tells you that at this material moment, then we will only not consider this if it is from 0.5 out upwards, right? So it means we are going to consider from 155 to 155.5. So this will give us 155.5 minus 151 divided by 15. So what will you get for this?
Is it 155.4.5?
0.5.
Okay.
Because it says between. If it is between and you keep it as or at 155.4, then it means that if it's between, you've not included the 0.4. But if it is 0.5, then the values that are between the 0.5, 0.4 is included, right?
Okay.
Are you getting that part?
So it's 0.
The 0.3.
So you had here as 0.3, let's say 0.0.
0,
So this
0.
we are now dealing with. So let's write the first one as P of so we have P of negative 2.1 less than, let's say this our Z, and this less than 0.30. So this is what we are interested in now. I want to clear this part so that we can draw our distribution and see the various conclusions that we can have.
Sir.
Yes.
Please. I think my network was messing up, so I didn't understand why you took 155.5.
I say we want values that are between 120 and 155. And I am saying that because this one is a continuous data, then it's likely you are going to get 155. Let me even start listing from 119.4, 119.5. You have 119.6. Now let's get to this part. We can have 155.1, 155.2, 155.3, 155.4, 155.5, and then let me add the last one, 155.6. So if you are looking out for values that are between 120, then we said there is a possibility that values that were from 119.5 were rounded up to give us 120. I hope that part you understood.
Yes, please.
Now let's get to this point. There is the possibility that values that were 155.1, 0.2, 0.3, and 0.4 were rounded down to give us 155. So this will be part of the 155. This will be part of 155. This will be part. And then this will be part, right?
Yes, sir.
Okay.
Yes, sir.
But because we are going to look out for values that are between 120 and 155, if we choose 155.4 as our upper bound, then it means the values that will be between will be to the left side. So it means we have added 0.3 and we will exclude 0.4. But if 0.4 is part, then you are considering your 155.5 as your upper bound, so that 1 point between means all these values supposed to be between your upper bound that you have set here. Are you getting it? It's like you finding your class boundary.
Okay.
So if you are finding your class boundary, you taking the 0.5 from this to give us 119.5, you equally add the 0.5 to the upper limit to get your upper boundary as 155.5 in order to include the values that will be between that one.
Okay.
So let's draw the distribution now and see what we will get.
So, sir, we are doing that because the data is continuous.
It's continuous.
So whenever we get a continuous data like this, that's how we're going to do it.
Yes.
Like height, for instance, height.
Yes, height, for instance.
That's
the
how
ones that.
So it means that when it is a continuous like this, you just have to use the lower and then upper class boundaries.
Yes, but it depends on how the question has been framed, though. This one, we are looking for values that are between 120 and then 155.
Okay, okay.
So you are going to get your distribution as this. So let's have our distribution, let's see here, so that here is the 0 that we have. Now, for this means that Z is greater than negative 2.1. So if this is our negative 2.1, then if it is greater than, it's going to be to this side, right? Now, this also means that Z is less than 0.30. So if this, assuming this is our 0.30, then to this side will be the less than aspect. So it means that the probability that we are looking for is falling between this point and then this point. So that is what we are. So we are coming to calculate for the area that is being bounded by this particular line and then this particular line. So first we will look out for our probability of the Z being greater than negative 2.1. So that is what we have to calculate first. After that, we calculate for Z being less than 0.30. But mind you, before we look out for Z greater than, then we have to look out for Z being less than or equal to negative 2.1. So let's deal with the 2.1 first. So let's go to the table. We are going to look for 2.1. We have 2.1 here. So 2.100. So this is the one that we will be looking at. So that is 0.9821. So someone should write that one down for us so that we look at the 0.3. So this is what we are having, right? So I hope someone has written it down.
Yes, sir.
Okay. Now the 0.3 would also give us this. So that is 0.6179. So write that one too so that we can 0.6179. Okay. So this gave us what was 0.1?
9821.
Okay. And this gave us
0.6179.
very good. So if we have the probability of z being less than or equal to negative 2.1 being 0.9821, then the probability that z will be greater than negative 2.1 will be 1 minus the probability of it being less than, right? So that would be 0.9821. And what are we getting for that? 0.02.
0.0179.
Okay, this is supposed to be 179 like this. Yes. So that is the probability. So for us to be able to find the probability of negative 2.1 less than z less than 0.30, then will be equal to the probability of z less than 0.3 minus the probability of z greater than negative 2.1. And that is equal to 6179 minus 0.0179. And what are you getting for it? This is 0.600.
It's 0.6.
Okay. So that is how we go about it. Any question on it?
Oh, the network here to call.
Football.
Hey, you're at the setback. Why, baby? Oh, stress, yes.
Mas foi não segura. Ah, um passe aqui. Call from point.
Hello. Hello.
Yes, sir. Say you are here.
Okay. So now let's proceed. We've been able to find the probability to get it at 0.600 as this. Have we answered the question? Hello.
Yes. Sir, please, you are coming. You are coming.
We are trying to process everything, sir.
Okay.
No, please.
Okay. Why?
Say we have to multiply it by 500.
By 500. Yes, because we've been asked to find number of what? Students. But this is the percentage or the probability. So the percentage of students who would take between 120 and 155 seconds to solve the problem is the 0.600 or the 60%. So we have to convert that 60% to numbers. So with that one will be the number of male students that solve the problem multiplied by 0.600. And what are you getting?
$300.
So you have 300.
300.
I said I wanted to hear the females, but you've not heard them. So the last one, I think they will do justice to the last one. Or today we are having only one female in our mess.
No, sir. Sir, Julie says she will solve the next question.
Okay.
Hello,
So
sir. Hello, sir.
Hello.
Yes, sir. Sir, please, I want to ask a question.
Okay.
Sir, by the explanation you've given to us, are you saying if we solve it without converting it to, that is the lower class boundary and the upper class boundary, and we just solve it, we are going to get it wrong?
Yes, please.
All right. Thank you.
So, Madam Judy, let's hear from you.
So the females are three: Laurentia and Johan and Julia.
Okay, then Laurentia, Julia, and then who?
Johanna.
Yes. Anyone?
What about Lodina? Lodina.
What's the name, Mahama? How are you?
She's not around.
Okay. But they are supposed to be 5.
They are more than 5. We have Anita. We have Lodina. We have Miriam. And I think the other one, forgotten the name.
Okay, so let's hear anyone. Or this one, you keep it to yourself and you do it at your leisure time.
Sir,
Okay.
so more than 185. So we say 185.5.
So your Z will be equal to 185.5
minus 181 divided by
1 divided by
50.
Okay. Mr. Bright, kindly mute your microphone.
So you get 2.3.
2.3. Okay. So it means you are going to now calculate for probability of Z being greater than. Okay, then it's from Xavier's end. Xavier, your background is quite noisy. Okay. And then from the table, what did you get for this?
Sir, please, I don't have the table.
Oh, 2.3. So you had 2.300. So that is supposed to be 0.9893. So we have 0.9893, right? So let's see. This is what we have. This is the mean 0, and we are having 2.3. The area that we are interested in, we said more than, so it means to the right side of this 2.3 is what we are interested in. But we know that we can calculate the whole of this, and we've had it to be, no, sorry, the z of less than is what we have been able to find. So to get the probability of z greater than 2.3, then we are going to have it as 1 minus the probability of it being less than, so 0.9893. And what are you getting?
Zero point 1117.
No, it's 0.0107.
0.0107.
Yes, please.
Okay. So now you have this, but we were asked to find the number of students who can actually solve the problem in more than, or who will take more than 185 seconds to solve the problem. So that's the number of students is going to give us 500 multiplying 0.0107. What are you getting?
Five point 35. 5.35.
So meaning it's taking us approximately 5 students, right?
Yes, sir.
So that is it. So you are taking approximately 5 students to get it solved. All right. So there are some other questions that you can use what we call the normal distribution, so the binomial distribution, to approximate the normal distribution. So these ones, if you get it, you should be able to do justice to it. That you know that the mean is equal to NP, of which we just did last week. Then the standard deviation is the square root of NPQ. So if you get it, you should be able to find your mu and then the standard deviation before you solve the question. So let's see how the question was even framed. A fair point is tossed 500 times.
Hello, sir.
Find the probability that the number of heads will not differ from 150 by more than 10. And then more than 30. So this, first you have to see
Hello,
that
sir.
it has a certain number of trials, that is 500. Once it is a fair point, then the probability of success will be equal to 1 on 2, and then the probability of failure will be equal to 1 on 2. So you have this, and then you have this. So the rest is for you to now calculate your standard deviation as this. And then fortunately, say will not differ from this. So it means this is now guiding you as what? Your mean. So you will not differ. So if your mean is 150, it will not differ more than 10. and will not differ more than 30. So you have that, so you can use it to approximate it, then you go with it. Hello. Yes. Good afternoon. Sorry. May I have the phone? I'm well. Right. So there are exercises that you can try your hands on. So we want to look at the T distribution. The T distribution. So all these are exercises that you can try your hands on. Or you look at the T distribution. So for us, yes.
Please, before you move on,
Okay.
kindly write this for me. I want to ask a question based on that, please. Let's say if you have a probability of 8 less than 8 less than x less than 8.6. Okay, very good. Now say, if you are to solve this, you see, you said when it's less than, when there's, after looking at the answer on the Z table.
Okay.
So now you realize that it is Z going to be greater than when you find 8 on the Z table.
Yes.
Why is it that when you get here, you don't consider the greater than?
I don't understand. Which part of the greater than have you not considered?
That is, okay, so let's solve for this. I know when we solve for Z minus, let's say, the mean is also 8. Like the first one, I'm using the first example we used.
Okay.
Yeah. So if the, let's
So
say
you
8
have
minus
probability of 0 less than Z less, this was 0.12.
Very good. Say, you see, the Z, if you pick only the Z greater than 0.
Okay.
Okay. Z greater than 0, yeah.
So
say,
P of Z greater than 0.
So why is it that when we get here, we don't consider the greater than so that we can subtract from 1 before, what do you call?
If it is greater than 0, right?
Yes, sir.
And you subtract from 1, you are still going to get it as 0.5, isn't it?
See, the reason why I'm asking this
This
question
is
is
what we
because
have. If you draw your distribution as this, and this is the 0, and the entire area is 1, then it means the side to the left here, all the area is 0.5, and this
yes,
one is
please.
0.5. So if you are thinking of it being greater than 0, then the area that is greater than 0 is 0.5. And if you are looking at the area less than 0, that one too is 0.5. Hello?
Sir, I'm listening, please.
Yeah, so for you consider if it is 0, as to whether it is less than 0 or greater than 0, because we said it is symmetric about its mean, then the area will be the same. If you are considering less than 0.5, it is the same as it being greater than the 0. So if it's less than 0 or greater than 0, you get the same thing.
Okay.
Or there is a particular question that you wanted to talk about, then that one we can go about. But if it is 0, no matter how you turn it, you get the same 0.5.
Okay. So, okay, then I think the last question we answered.
Okay.
The last question we answered. I think let's use that one so that's because I'm facing some slight issues there.
All right. So should we go back to the question?
Yes, please.
Okay.
Sorry, colleagues. I just want to clear my issue here, please.
Is it this one?
Yeah, the one we use, the first one, the A.
Okay.
Between.
Okay.
So say this one. The other one we wrote negative 2.1 less than Z.
Yes.
Then Z less than 0.30.
Yes.
Yes, I said that aspect. And when we came to B, the B, it was more than. So that one we considered the what do you call the Z being greater than 185. Why is it that here we didn't consider that?
Come again. You said we considered C.
So if it is greater than, if Z is greater than, we subtract from 1, right?
Yes.
So here, okay, I'll send it. It's right there. I've seen it.
This
Thank you,
one.
sir. Yes, please. Yes, I've seen it.
Okay. This is the one that you were looking for.
Yes, please.
Okay.
So, Minta, learning has taken place, eh?
Is that what?
Learning has taken place. But you've seen it, yeah?
I have.
So for the T distribution, you realize that the Z distribution that we have been dealing with, that one, the population mean, which is mu, is always known. The population standard deviation, that is sigma, is always known. And then the sample size has always been greater than 30 or equal to 30. But there are situations whereby you can have a distribution and then the population mean might not be known. And then even the population standard deviation too will not be known. And your sample size is such that it is less than 30. When that happens, we know that we can approximate the population mean using the sample statistic. And then we can also approximate the population standard deviation using the sample statistic. So if we will be able to approximate all this using the statistic, then if the sample size is also less than 30, then we resort to what we call the T distribution or the student T distribution. Now for the student T distribution, it works with degrees of freedom. So your degree of freedom will be given as n-1. So assuming you have a sample size of 15, then if you are to tabulate the results for your T distribution, then you are going to have a T distribution of 15 minus 1. So you have T of 14. So this your 14 is the degrees of freedom. That one too, will be using tables to find the corresponding T statistic. And then we will also perform calculations as well. But if you are talking about the table, then we will be using a degree of freedom. So pay attention if we get to a point where we are to calculate or get values from the table, then we will not forget the degrees of freedom. Now that one too has some properties that are quite similar to that of the Z distribution. For this distribution, it is continuous in nature, as in the case of the Z distribution. But this one said there are infinitely many T distributions, which is determined by degrees of freedom. Yes, because your sample size will be given. If your sample size is, let's say, 20, then the T tabulated value that you are going to get is going to give you a T tabulated with the degrees of freedom of 19. If your sample size is 19, it's going to give you 18 in that order. So it means we can tabulate so many forms of T values for whatever distribution that you have. And said the higher the degrees of freedom, the more compact the bell shape becomes. This is the Z distribution. We have the T distribution here. If the sample size is close to 30, you realize that the Z distribution is now flattening a bit, but though it's quite steep as at this point. But if your sample size gets smaller, then you realize that it tends to flatten. So that is what this point is trying to mean, that the higher the degrees of freedom, the more bell shape that you have. Because if your sample size is closer to 30, then your degrees of freedom will be higher. And it is more spread out and flatter at the center than the standard normal distribution as we've done. It is bell-shaped and symmetrical in nature. That one too is also bell-shaped and symmetrical, because if a line of symmetry is to be drawn along the mean, then if you fold it, this side will perfectly fit to the right side as well. So you see any calculations. Okay. So we have an activity that we are all supposed to undertake. We are to use the T distribution table with degrees of freedom 9 to read T values for each of the following. Okay, let me see if, because I'm sending you the T distribution table.
Okay, sir.
Joshua, don't keep it for yourself. Make sure you share.
He will share it right now because we are about to use it.
Okay, sir. Thank you.
Hey, Joseph. Joseph, you have it now, eh?
Yes, please. Yes, please. Thank you.
Okay. So now let's see. We've been asked to read these values. That is the shaded area on the right is 0.05. So first, before you can do that readings, you have to first of all have a sketch of whatever readings that you are coming to have. So we said the shaded part is 0.05. So it means that you are having the shaded part here as 0.05. So we are supposed to read it against the degree of freedom of 9. Let me see if I can project the table so that we see how to do the readings.
So what if we can look at it on the table? Okay.
Yes. So now this is how we do the calculations. You look at the area that has been shaded will be the ones that will be on the column, and then the degrees of freedom will be your rows. So if you look at this row, we are having a degree of freedom of 9. So we are coming to read the degree of freedom, which is 9, against that critical region or whatever probability that we've been asked to. That is 0.05. So if you trace it, the point of intersection is this one, right? So you have it as 1.833. Did you all get that?
Yes, sir.
We have this as our T with 9 degrees of freedom, 0.05 is giving us. What is the value that we had?
1.833.
1.833.
1.833. Okay. Now we look at that of the second part. That the total shaded area is 0.95.
Sir, please, I'm still seeing the table on the screen. So
Okay.
How many screens are you having there? I see on the screens.
Okay. So now we have to look at the situation whereby the total shaded area is 0.95. So if you have your distribution like this, and then you have this, and they say the total shaded area is equal to the 0.95. So it means that if your shadings is starting from this point, then you are shading it in such a way that wow, so my microphone is off. If you are looking at the total shaded area to be 0.95. So if this is your entire curve, then if your shadings is starting from this point, then it means you are going to shade up to this particular point, right? So let's say 0.95 is here. Now we are going to do that against a degree of freedom, which is 9. But if you look at this carefully, you realize that the table that we presented here is a right tail test. So from this point up to this, if it is 0.95, then it is the same as we looking for an area that is left here. So because everything combined will give us 1, then the area that will be left here will now be the same as 1 minus 0.95, which is equal to 0.05. So this will be the same as the first question that we did, and it's the different way.
Sir,
Yes.
this one, how you draw the diagram, I don't really get it.
Is it about the total area or the shadings?
Where will, sir, please, where will our 0 be?
Where will?
See, the first one, see where you drew the 0.05.
Mm-hmm.
Well, I thought this one to our 0 is at the middle.
So you wanted the mean to be somewhere here at 0. Is that what you wanted? This thing has to do with probabilities, right? The z-scores that we were dealing with, we were looking out for individual scores here and then calculate its probability. So the shaded area represented the probability. So if you quite remember, for the z distribution, if we had, let's say this, and we were having, here is 0 and let's say 2.5, and we want p of z greater than 2.5, then we will shade this area that this is what we are looking for, right? So
Yes,
if we calculate for the probability, then the whole of this shaded region is the probability that we have calculated for. But this question here is telling us that a shaded region has been given, and we are to look out for, in terms of the z distribution, so the t distribution, the t value that corresponds to this particular shaded region. Are you getting it? This one, we've not done calculations pertaining to how to convert from raw values to, let's say, T distribution and then look out for its corresponding probability. This one is just trying to elaborate on how to read from a table. And we've been given a particular degree of freedom and then a certain shaded region that we are to calculate for a value that corresponds to it. So this thing that we had as it was 0.1833. So it means that this point is the 0.1833. But the area that is being bounded by this line and then to the right of the curve is the 0.05.
I get it all, but my problem is how you draw the diagram. That's my problem.
How you draw. But we know that even from the normal Z distribution, for the diagram like this, the entire area under this particular curve is equal to 1. Is that not the case?
Okay, yeah.
Yes, so if it's equal to 1, and we've been asked to find the T distribution that corresponds to the area that is shaded on the right, which is 0.5. Then if we pick the right like this, here is 0.5. So to a point at this point, and if the shaded area is 0.05, then it means it will be to the tail end of what? The right side.
Yes.
And then the C part is asking us to look at the T distribution that corresponds to the total unshaded area is 0.99. So the total unshaded area is 0.99. So how do we calculate for that? We have this as our distribution. So we said the total unshaded area is 0.99. But we know everything under this curve to be equal to 1. So if 0.99 has not been shaded, then it means that the part that has been shaded will be 1 minus 0.99, isn't it? So this will give us 0.001. But if it is a two-tailed test, such that part of the right side has been shaded and then part of the left side has been shaded, then it means that if you are to calculate for the part that has been shaded, then each portion will represent 0.001 divided by 2. So that is going to give us 0.005. So this shaded will be 0.0005, and this will be 0.0005. So you are now coming to calculate for a probability that corresponds to this. So because it is two-tailed, you get negative and then positive. So you pick your table. You all have the table, so give me that value and let's see. 0.0005 as against degrees of freedom 9.
So 4.781. Hello, sir.
Yeah, hello.
4.781.
4.781. Okay, 4. So you get this as 4.781. So, but this, will it give us 0.005 or 0.0005? Will it be 3 decimals or 4? This one. So this should have been 0.1. 0.01. Is that not the case? Because 1 minus 0.99 will give us 0.01. So that this will be 0.005.
05.
Yes, so do it that way. 0.005.
3.250.
So you have 3. So
Point.
T will be equal to
3.250.
250. So if it is at this point, then it would have been positive. If it at this point, it will be negative. So this is the value that you get. That corresponds to 0.05. 0.005, sorry. And then the D part is talking about the shaded area on the left is 0.05. So if you have your distribution as this, and then the shaded parts on the left is 0.05. Then what will be the T value that corresponds to this?
The negative 1.833.
Okay, so T value to the left side of degrees of freedom 9 as against 0.05 will be equal to negative 1.833, like that. And then the last one, that is the area to the right of T, is 0.15. So if this is your distribution, then the area here is 0.15. So we are looking at for T of degrees of freedom 9 as against 0.15. So what will we get for that? What are we getting for that?
On the table, we don't have 0.15. So I think you find first 0.1 and also 0.05 and you add, right?
You don't have 0.15 on the table.
On the table.
Okay.
So what if you find 0.1 and you add it to 0.05?
If you add, what are you getting?
I think when I add, I should get, and calculator is away.
So you get 3.216. When you add both, you get 3.216.
0.15. So 0.1 gave you 1.9, and then
0.05
also give you
1.833.
That shouldn't give you, it shouldn't give you a value that too big like that.
So the 0.1 is 1.383.
1.383. Okay, so you had 1.383
plus 1.833.
1.833. And you say you are getting
3.216.
216. But if that happens, you've applied the degree of freedom twice. That it will not give you that. So try to look at how you get that value. It will not give you that value. It's supposed to give you 1.097, not that. Okay, so let's see how
By 2, we are getting 1.608.
1.
I try to divide it by 2.
No, this one was explicit that the area to the right of T is 0.15. So if the area to the right is so let's look at the various calculations and formulas that we use in calculating for the T. So as in the case of the Z, that we were using the Z to be equal to X bar, or the X minus mu divided by the standard deviation. So this one is whereby the population standard deviation and the population mean is known. But if it is not known, and then the sample size is such that it is less than 30, then we go by the T distribution. And the T distribution, this is how we calculate it. We calculate the T distribution as X bar minus mu divided by X on square root of n minus 1. And the distribution always has n minus 1 degrees of freedom. So if you are confronted with a task and you want to change it from whatever score to T score, then this is the formula that we use in converting to the T scores. So we have an example that has been given, that the company claims that this one has to do with confidence intervals and other stuff. So a company claims that its soap machine delivers on average exactly 4 ounces of soap. And then the company statistician finds that N is equal to 25. That is the sample size. And then the mean is 3.97. And then the standard deviation is 0.04. And we've been asked to calculate the value of T statistic. That is where the interest is for now, the T statistic. And we said that the T is giving us the X bar minus the mean divided by the standard deviation from the sample divided by n minus 1. So this will be equal to, now we know mean given in the question as X bar is 3.97 divided by, minus mu, and mu has been given as 4. That is the company's claim. So 4, and then this is going to give us the standard deviation as 0.04 divided by square root of n minus 1, and n is 25, so you have 24. So everything is going to give us, so T is equal to, what is 3.97 minus 4? So that would be negative
0. Negative 0.
Yes, so divided by, now 0.04 on square root of 24. What are we getting for that?
I punch all and it's giving me negative 3.674.
Negative. Okay, so let me do this as 0.04 divided by square root of 24. And this gives, you said negative
3.674.
674. Okay. So this is the T distribution that if you calculate, you will get. So that is how we go about the T distributions. So let's look at this. Okay. This question has been attempted here. So you have this minus this. Okay. But this one is going to create disparity in the solution, right? Because 3.93. Okay. You give an answer as negative 0.23.
3. So we said negative 0.03.
Say 0.03. I heard 0.23. So if it's 0.03, then check and let's see if the answer will be the same as this.
Let's say negative 3.674.
Okay.
Yes, that's correct.
So this is negative 3.704. And you said you had 64, right? 604.
Yes, 674.
674.
Four.
The Q is as a result of this approximation. So just punch this alone and let me see 0.04 divided by square root of 24.
So we had the answer. It includes times 10 raised to the power negative 3.
Okay, so that is
So 8.164965809.
I'm coming. 8.164
164 965 809.
809 times 10 raised to the exponent of negative.
Negative 3.
So it will be 1, 2, 3. So
Right.
it will be 0.0082. So this should have been 82 instead of 1.
Yeah, it should have been 82.
So that is where the disparity is coming. So if you replace here as 2, and will you get the same as negative 3.6? What is the answer that we have? 674. So make it negative 0.03 divided by 0.0082, and let's see what you get. It's supposed to be closer to this.
Yes, sir, that's what you will get, please.
Okay, so that is it. So depending on the kind of tax that you've been faced with, if it is Z distribution, you will know that your sample size is greater than 30 or equal to 30. You have the population mean given. You have the population standard deviation given. If your population mean and then standard deviation is not known, then you can find approximations for these parameters using sample statistics. And after that, you come and use your T distribution. So that is how we conclude for those things. I hope you've done confidence intervals and other stuff. You've not done hypothesis testing there.
No, sir.
So if a time that you are to deal with confidence interval, that is the interval estimations and others. It's still not done interval estimation, are you sure? Then hypothesis testing will come in and you will be using the Z and then the T distributions more frequently. So please don't throw them away. I'm really tired. So we want to look at the chi-square probably next week when we meet.
All right, sir. Thank you, sir.
Hello, sir.
Yes.
You made mention that after the class, then we discuss about the day, whether you should use the holiday or something.
Yes. So I will check from my, tomorrow is Sunday. Let's see.
Okay.
We'll have to check from my end at our place too. It looks like the holiday still, we will still be teaching, but I will check if the time, even if we can have it in the evening, I will check and see and then get back to you.
Okay, sir. Enjoy your night.
This job, do we even enjoy? Does teachers enjoy?
Our reward is in heaven, but now we are taking it from the earth.
You cannot enjoy. You finish and you have marking plenty to do, so you cannot enjoy.
Hey, Savior is there, he can assist. Savior and Joseph, they don't do anything. No work for them.
Masa. Joshua, by George
Yeah,
Tuesday, why don't you call George to assist him?
I want my peace. Oh, I beg.
George, why campaign?
Me kwa kacha George de Joshua Nese hade.
I said I want my peace. I want my peace.
Why campaign? Munya no campaign.
Please, anything you say now will be used against you because it is being recorded.
Yeah, oba.
Check the recording icon.
Yeah, they are still recording it.
Yes. First rep.
Yes.
Why are they releasing the last 4 results?
He said when?
Yeah.
This is a big question.
I want to know my stand.
Your stand is that you've gone through. We've all gone through. That's your stand.
I'm seeing just cookies Nimians. I'm here bad pa.
Hey, Patrick.
I'm gonna say about Bimba.
No, we all go through. Just that you need to be calm.
Say be ebo ambo see to
I'm sure they'll not feel anybody.
Oh yeah, we're all going through. Aye.
Nah, I did actually we are all going through this.
Hey, so it's one part.
I was sweating. I don't know why that's I said, my life, me I'm saying though.
That is UCC for you. They'll make you learn.
You know, I'm sorry that you know, but
you say when you blog when I'm for big Japan.
Blog where
yeah. Hey, you know, baby, I'm not taking it like as a man for funny joke.
Debut. I'm going to say I don't know. I don't know you back where you who she sana kwe.
Me because me which name me pio. Me now my feeling.
So fortunately, we say Oma is in the last lecture, but fortunately, next week Rebecca come home, and the following week, I first quiz. I think there's another 3 weeks for us. Until we start. If you look at the calendar, we have our first quiz, which was supposed to be next 2 weeks, and now to be next 3 weeks.
Oh, okay.
I don't know whether you stated
next
it.
2 weeks, yeah.
No, next 3 weeks, not next 2 weeks.
So after the first week, the 4th week.
Okay, so instead of the normal 4 weeks, now they are doing it 5 weeks for us.
Yes, for what I have. Let me confirm it.
Okay.
So I think our first quiz will be 11 to 12 April.
So after the first 5 weeks.
Hello.
Yeah.
So we realize that next week would be our practicals if you are supposed to. And now they are going to teach us.
Okay.
Then the following week would have been our first quiz.
Oh, that's nice.
All right.
But now it will not be the following week, but I think it will be the following 2 weeks, which is the 11th of April. So it's like we need to set up, especially some of them, especially federal calculus and this thing, federal calculus especially.
I said after
we are in together.
Some people are waiting for the exam, the result to stop, but
I will not encourage you to stop. No matter what, when you start something, you have to. Some people even go through it. Some people go through and they get just pass. They have the certificate, and you move on. Abstract, looking at how abstract is, definitely you get some questions to answer. You look at the proofs. Some of them, you look at the proofs. You get some of the questions to answer.
Constraint.
Test me or then.
Right now, I'm just thinking about the facilities.
Yeah, so everybody will get. And if I know someone who gets hard pass in at UCC, the person went to Canada. The person is having first class in his masters. The best student in a graduating student with the masters. I'm telling you. UCC. Yeah. So you see the pressure you learning there, you learn. That's why when you come out, you're confident. Say you completed UCC, not the other universities.
Yeah. Even we have done. We have even done half of Akiola mathematics, so elective mathematics. We have done half of it.
More than half.
More than half.
More than half. And we've gone deeper.
Hey.
Some of them they are not in it. We've gone deeper.
Yeah. We've gone. We've gone 3 steps. You were saying something like the
now,
person had passed,
in
right?
each of us, if we have been allowed to.
Josh.
Yes.
Josh.
Is it even now? Yeah, Charlie.
You go explain tire. You go stop.
Oh, but
you go explain
Mohammed.
tire. You go stop.
Mohammed,
you go explain tire. You go stop.
You Mohammed, I'm coming for you to teach me. I tell me I go explain tire.
You go explain. You go explain tire. You go stop.
But
Mohammed,
let's be realistic.
Mohammed,
what is going on?
Set.
Our next meeting. Mohammed.
Yo.
Xavier.
Our next meeting.
Let's be realistic. Let's be realistic.
The
little that we have.
Oh, the meeting now. If the big salary, this one is the small one.
When the big salary go happen?
So God willing, some 2 months time. But now we see the campus.
So
big go flow. Yeah, Josh.
Mese kakra ye nyen no koto senior high school ben na untumi nchira.
Oh masa you suadio. Yendo.
Yeah, the little. Master, what I'm saying is if you make sure you get a certificate, forget. When you go there, you deliver.
But Josh.
Yeah.
I don't know. I'm having some kind of reservation. I don't know if it is Dr. Bright installed there. It'd be like if we speed up small because vectors and further algebra, further calculus, we dey far.
We dey what?
We dey far.
We are lagging behind or we dey far.
We dey behind the crowd.
Oh, but senior man, it's not about you being lagging or going faster.
He made mention of
we understand it.
He said something that if
those doing the online,
if you want him to lecture, he can finish it within some few minutes. So actually, he's teaching us. But if you want him to lecture, I can just tell him to lecture us, and you complete it and you don't understand anything. Like last week when he joined the main online something.
Hey,
when I joined the online, I didn't understand anything. But today when I was looking at the differential equation, I realized that the understanding was clear.
Yes.
So if I believe in get the understanding. The other ones will help you. Last year, I met one of our colleagues, and he was able to open one of the things to me. And when Dr. Bright was teaching, I guess I had understanding. I met Miriam. Miriam taught me. You think I'm joking? Mohammed, Miriam didn't tell you.
It's because you have cars, so we'll be moving from house to house.
I'm a Jehovah's Witness. I move from house to house.
Your responses to doing every online class, it seems like you're getting what the lecturer is doing.
Me?
Yeah, for your responses. How you give the feedback left and right?
Oh, sometimes you can follow, sometimes you go off. It's not easy.
I will be following that thing. Then I'll reach some point and I deviate.
Last weekend, I observed that all of you guys, like, you were there, but you were not responding to a doctor.
Some of us are travelers.
Hey, Then
last week I didn't
then
get anything from there. What do you call
then I have to sit down. Then take the whole.
Me what I
Oh,
was doing
Josh,
like I
Josh,
was using
if your name
AI.
way,
friends.
Josh, if your name way, you mention most too. So you practice at all time.
But I off. I the Indian como. And
Josh,
yanko offline. It's that one.
Josh,
Yanko offline. I know record. Only
Oh,
time
hey,
I recorded the
man,
media on wine. Yanko offline.
oh, man, say anyway, and
And yanko offline.
hey, Josh, now in Canada though.
oh, man, say and can't someone,
Yanka akabona.
Okay, you didn't come and share. Paddy be say lecture no. As I do for. I say hey.
But you could data, Mr. Rewana, on all the time in the Atenas, and you have to learn. We also get there.
Please, I'm at Koforidua campus, so.
I didn't another lecture.
But say you say Esha this block we the only problem is further calculus.
That is it. That is the only problem.
But apart from within there, even start 2 within there obey application.
Yeah, obey application.
Obey application.
And so no be other no do.
Vectors no so you okay.
OD now there. Obiama be 6% effort oh. OD OD now.
This week
OD in me fit oh. Me fully fit oh.
Kakane nya na the farmer me farm so me the more I.
Martin, no problem. Yam boy e share e bakasa.
Sebia, member empoho. This time the transfer them reba.
Eba na muko. Mo pede you say on your way na e share face to face and watch them modulo we no because me pass question me oba.
Modulo until that anya heavy bia.
Modulo no, I remember Uniba may hear me degree or Uniban. Hey, almost set a question. Me pre and make be answer. Obi be feeling. You buy in Nipa that particular course. No Nipa 5 per I and 5 people at 4 people in your A. Yeah, 273. Nipa 155. Yeah, film.
Say, Obadrin say you full. Instead me say, say starting and can say.
I remember someone said the question was very difficult. It's application. If you don't understand the concept, I want to me. Until they thought said, a friend over na question my results on notice board. No friends, but you had A names no, but I was not crying for them. I was the course, so I was crying for those I was teaching at then. Even on no even about na about UCC. I want.
Even there or full, but
no abstract no. Obey an abstract, no numbers. That is how it's going to be. I've had that experience before. Obey an abstract, no numbers. So the result you're going to get will be abstract. But no, on the moment I don't have problems. So already on that, I can also help in that. Mohammed says, "So let's make sure and I also ask them a further calculus."
It's a further calculus in the day to go low.
This is Madam Miriam no champion no. Yen win.
Oh, me more champion. Yeah, obey further on course rep. Why? What when you pass one more? I'm not meant to me.
Oh, Obia be sell through with good class.
Pass Muhammad.
Master. Pass rejected.
Yeah. If I'm saying to me, you show that they cover with people don't they? See also.
Okay, Tibisia.
Martin, Rebecca said backdoor eye.
Okay.
Well, I'm back now.